Okay, so today we start with risk management, right? Now, every task that you take has got some associated risk that could happen or things that could go wrong within the uh, system. Okay, uh, so here we are actually uh, trying to understand what all precautions we should take while carrying out a project, right? So in the process, we try to understand what is the definition of risk, right? And what is the whole process called as a risk management? Now, some ways of categorizing risk, that is risk management, risk identification, analysis, planning, monitoring. How do you handle risks, right? You should be able to identify risks, then analyze them to understand which is serious. Now, based on that, you give priority to the solution or issues related to solving that risk. Then risk planning, what should we do in case something happens, and then risk monitoring. Has the planning worked, right? So whatever measures you have taken, has that been effective or not? That is also something which you have to look into. We also look at a PERT risk and what do you call it? Critical change. Now, some definitions of risk. The chance of exposure to adverse consequences of future events, Prince 2. Then an uncertain, as per Prince 2, this is the definition, the chance of exposure to adverse consequences of future events, right? Normally, risks are always looked upon as negative incidents, right? But some could be positive also, uh, something which you don't expect to happen, right? Now, though it is for good, you might not be prepared to handle it. Then you say it was a kind of risk that you took, right? Now, in our life, we say, uh, sometimes we take decisions which we are not very sure about, right? Some might click, some might not click. So those who click are positive actually, and those who don't click are, but both are a result of risk taking. But mostly, I would say 90% in cases, they look on risk as uh, with a negative mindset. An uncertain event or condition that, if it occurs, has a positive or negative effect on projects uh, objectives. Now that is as per PMBOK, right? Then risks relate to possible future problems, not current ones. So risks are always related to what could happen, what may happen, not what is happening now, right? They involve a possible cause and its effects. Example, developer leaves, resulting in task delay. Developer leaving is a risk that could happen. Project manager leaving could be a what do you call a risk that could uh, happen, right? So risks are always there. Nothing is kind of uh, there is nothing called safe zone in an industry. Risks are continuously things that keep happening. Now, categories of risks. You have actors, you have a structure, you have technology, you have tasks, right? Now, based on that, you have schedule risk, budget risk, operational risk, programmatic risk, other risks. Now, schedule risk is you scheduling something as per a time aspect, and then it doesn't go according to your plan. So that is schedule risk. Budget risk. You plan with so much amount of money or finance for that, but that never works out again. Now, operational risk. Now, here, these are related to day-to-day activities that happen in your organization. One is insufficient resources, right? While working on something, you don't have that many people. Then conflict between tasks and employees. I get something which I'm not interested in, or I get something which I'm not responsible for. So I tend to withdraw myself from the whole process. Conflict between tasks and employees. Then improper management of tasks. You're not able to manage the tasks properly. No proper planning about the project. Now, that is a mistake that you do, but that, or you planned things, but that actually did not work out. So that is again an operational risk. Less number of skilled people. You don't have people with skills. Then lack of communication and cooperation. This is interpersonal in an organization and which is very common, right? Then lack of clarity in roles and responsibilities. You have assigned tasks to people, but they are not very clear about what is happening. Then insufficient training, right? People are not trained properly to handle that particular project. Then other risks are communication risks. Things have not been communicated properly. Then security risks, quality risks, cost risks, market risks, risk associated with law and compliance. So all these are aspects of or examples of various type of risk. Now, based on that, we categorize them: schedule, budget, operational, programmatic, and other risks. Programmatic risks are basically related to the coding aspect of things. Now, a framework for dealing with risk. You should have a clear idea about what the risks could be, right? Actually, they make a list, and there are risks which are bound to happen and not bound to happen also. But you should always be prepared in case it happens. What will you do? Now, that should be your concern, actually. So, a proper understanding of risks should be very is actually very important. Now, risk identification. What risk might there be? Risk analysis and prioritization. Which are the most serious risks? Then risk planning. What are we going to do about them? Right? If at all those risks happen, what will we do? Now, there are risks which we can handle. There are some risks which we cannot handle. Say, for example, power failure, which is coming from an external agency. What will we do? How will we manage it? The only thing we can probably do is have a generator, an uninterrupted power supply, etc. Right? Then risk monitoring. What is the current state of the risk? See, a risk has happened, and see, many a times we look at risks from this point of view. That is, risks are bound to happen, right? The challenge is how can you bring your system back to normal after the risk happens? The faster you can, that means you have a better risk management procedure. Things will go wrong. That is bound to happen. You have no option there. But you always look at how can you bring back things to normal. If a flood happens, what do they try to do first? They try to save lives. Affected people, reduce the affected people. They can't do anything about the houses there, right? Because the flood will definitely damage the houses that are happening. But the priority there is not to save houses, save the lives of people. And then the next challenge is how these people can be taken back to their homes. How fast can you do it? Now, if you can do it with the least amount of time, that means you have a proper risk management plan or risk management system in place. So the ultimate challenge faced by most risk managers is how fast they can bring the system back into function. So the planning risk include these steps. One is risk identification. Identifying the risk is very important because only then you will be able to clearly and categorize the risk also, right? Only when you start seeing a risk, planning the risk, handling a risk, right? Evaluating a risk, prioritizing a risk, all these can happen only if you have identified the risk first. If a risk is not identified, then that means you are not ready to handle that particular risk. The risk analysis and prioritization. Analyze the risk, understand its impact, and then that will help you to prioritize the risk. It will help you to uh, decide how much of importance you must give to that risk. Like I told you earlier, when a flood comes, saving people's life is the most important thing. House, cleaning the house, taking care of the house, residential area, roads, etc. is secondary. So that is because common sense tells you that people's lives are important. But in an organization, there might be so many processes happening, it might not be clearly defined as to how critical the risk is. That depends on experience and senior people who will decide upon how and what a risk has to be handled. Right? Okay. Now, so risk analysis and prioritization. So once you analyze the risk, you will be able to prioritize it. So you understand what is to be handled first, what is to be handled next, and so on and so forth. The most important thing is to be handled in the beginning itself. Which are the most serious risks that you must be able to understand? The most serious risks that can handle the situation. Then risk planning. What are we going to do about them? Now we have identified the risks, we have prioritized the risk, everything. Now how are we going to handle them? Now remember, you don't expect any risk to happen, but in case it happens, you all should be prepared. That is the whole objective here. Now every building has got firefighting system. It's not that we want the fire to happen or we want to do it. No, it is just a precautionary measure that we keep, because having a firefighting system, we can reduce the damage that can cause to the building. Otherwise, what is the option you have? When the fire goes on, then you call the fire force. They have to come. There is going to be a huge delay in the process. By that time, the building might have completely got damaged. So if you have your own firefighting system, then you will be able to handle that situation much easier. So as a part of planning, you are maintaining firefighting systems within the organizations or within it. Why do you have a fire escape ladder in most of the high-rise buildings? Primarily because lift cannot be used when the building catches fire. Of course, depends on where the fire is catching. If it is within the proximity of the lift room or lift control center, then definitely you have to take care of that. You should be able to handle that. So we plan to have a proper firefighting system, because one is I was talking about the safe fire escape ladder. The ladder is there because that is comparatively safer than the lift being used during a fire. And that should be easily accessible also. In many buildings, we see these gates are locked, which take you to the fire escape, which is actually foolish. When the fire catches, who's going to get the key and who knows where the key is? Everybody will be running around for their lives. So that is also something which you have to look into. And many buildings, there are firefighting systems, but people don't know how to use it. There are fire extinguishers. They don't know how to use it. They have seen it. They're seeing it every day. But if a fire goes off, they just see it. That's all. They don't know how to operate it. That is why proper training is given. I think most of you might have undergone a training when you joined the organization related to safety and security measures. And at that point of time, the boss is actually the safety officer, not your project manager or CEO. Because they know how to handle things, they have plans for things. So you have to just listen to them, not even ask questions, because they are worried about your safety. So you don't ask questions, you just listen to what they say, because they know various aspects of risks. So all that happens as a part of planning the risks. So if something goes wrong, how are you going to handle it? Then risk monitoring. What is the current state of the risk? See, as long as the fire is there in the building, you keep on monitoring it. Why do you monitor it? You need to assess what is the situation now so that you can take remedial measures to mitigate it again. Mitigation basically means reducing the damage. This keeps on happening and it has to happen, even if the risk never happens. Remember that. None of us expect something to go wrong. But if something goes wrong, we should be ready for handling that particular situation. Risk identification. Approaches to identifying risk include use of checklist, usually based on experience of past projects, brainstorming, getting knowledgeable stakeholders, sit together and pool their concerns, then casual mapping, identifying possible chains of cause and effect. So use of checklist, which is usually based on experience. An experienced person will have a list with him. So he'll just keep ticking at various options that have been looked into, and he tries to identify if there is something beyond that. Right? Then brainstorming. A team sits together and put their ideas across continuously. Right? They go into discussions and try to identify risks and prioritize risks, etc., etc. Then casual mapping. Identify possible chains of cause and effect. Power failure. That's something which we can expect every day. That's a risk because work should not suffer if power is not there. Right? A person falling sick and he was very critical on that day. His presence was very critical on that day, and that day he's falling sick. What do you do? So you should have plans for this. Now, these are all casual things that happen on a day-to-day basis. Operational risk, what you call. Now, Boehm's top 10 development risk. One is personal shortfall. Staffing with top talent, job matching, team building, training and career development, early scheduling of key personnel. Right? If you look into this, then you can reduce the chances of risks happening in that area. Now, what is the risk there? Personal shortfall. That means you don't have sufficient people to work for you. So how do you handle it? You staff people who are very talented so that even if he is not, if one person goes off and there is another person available to you who can handle that situation very well. Right? You have a project manager. So that doesn't mean all the projects can be handled by him. You need different project managers depending on the number of projects you have. If it is one or two, maybe one project manager can handle it. More than that, you need more people there. Right? So if you have a good set of project managers, 3 or 4 project managers, so even if one person is not available for a particular time or he leaves the organization, there are other people to take over. But you should fill that gap at the earliest. So there should be a proper HR planning for that also. You must know what skills you require, which are critical for you, which you cannot adjust without. You need more and more people of that sort. So with top talent, job matching, they should be very clearly identifiable or relatable to certain jobs. Then team building is very important. The team always works together, right? Even if one person leaves, depending on the influence that person had on that team, it will definitely affect that person. Early scheduling of key personnel. Right? Then multiple estimation techniques designed to cost, incremental development, recording and analysis of past projects, standardization of methods. Now, this is unrealistic time and cost estimate. That is a risk. That means you planned things, but you were very unrealistic. You planned something in 10 days, which actually would take 15 days. So that is called unrealistic, right? Just because you want to show efficiency of your skills, you started planning, keeping the minimum of resources, minimum utilization, etc. But is it practically possible to do it according to your plan? Many times that never happens. If it's an experienced person, definitely he will do it accordingly. But you will see beginners getting into this sort of troubles. They try to reduce. They simply start meddling with the project plans, and then they say, why do you take 8 days for this? You need only 4 days. They try to cut short. But what happens is you will not be able to complete that particular project in the specified. So how do you handle it? Unrealistic time and cost factor. Time aspect is one thing, and cost. You charge 5 lakhs, but actually the project would cost you 8 lakhs. So that means your cost estimate completely went wrong, and you are bound uh, to make a loss in the particular implementation of the project. Now, multiple estimation techniques designed to cost. You must have different estimation techniques so that you will be able to clearly find which one is the best. Don't just go by one single method. Then design to cost. Your design should be in such a way that it stands within the cost that incurs on you. Incremental development. Make a stage by stage development. Don't plan everything in the beginning itself. Start small and then keep on adding increments to it. Recording and analysis of past projects. Recording and analysis of past projects. You keep a track of previous projects for reference and analyze what went wrong or how that project worked out efficiently and so on and so forth. That helps you in future projects. Then standardization of methods. Have certain standards working within the organization. You do these things in this way only, because what happens is if you give that job of handling situations to people, everybody will do it at their convenience. That might not be good for the organization. So the organization has to have certain standard proven methods of handling situations. So those are called standards. Standards necessarily doesn't mean global standards or national standards, nothing like that. An organization for a particular type of project could have its own standard. But without standards, people don't have anything to look forward to. Standards help them to compare what they are doing with what is actually to be done. Now, improved software evaluation, formal specification methods, user surveys, prototyping, early user manuals. Develop the wrong software instructions, functions. Now, this normally happens when you have either not understood the problem properly or you have not documented it properly. Because there is a team who goes to the client's place, understands the problem, and comes back and explains it to the team within the organization. Now, this factor is very important. What you understand, the people who go there should have domain knowledge of that particular area, without which they will not be able to make head or tail out of what is happening. So they should have a clear idea about what is happening. And then they should also have an idea about what they are going to do, so that they will be able to justify whether what is required and what they are going to do matches. And also find out whether that is a suitable solution in itself. Right, so those things have to be taken care of. So improved software evaluation, formal specification methods, user surveys, prototyping, early user manuals. Start documenting the project early so that if you are missing out something, you will be able to identify that. Then developing the wrong user interface, prototyping, task analysis, user involvement. Prototyping is basically creating a small workable model of the software that will give you an idea about how the user interface is going to look like, and then you pass it on to the user. The user will look and understand how things are working, and he is the best person to give you suggestions about how convenient it is for him to use your software. The software basically means the user interface for the user. He doesn't know anything about what is happening in the background. Now, prototyping, task analysis, user involvement. Now, Boehm's top 10 risks continue. One is gold plating, requirement scrubbing, prototyping, design to cost. Gold plating basically means creating a clear idea about all the one is requirement scrubbing, understand requirements in depth. Sometimes what happens is when you analyze it, you will find that that is not required at all. Then why do it? Why waste time on that? So that is because of that is basically that is called requirement scrubbing, cleaning it as much as possible so that you don't land up doing unwanted things. Then prototyping, create a small workable model so that the user gets a feel of what is actually going to happen. Then design to cost. Your design should be limited to the cost that has incurred on the system. Now lay changes to requirements, change control, incremental development. Right now, many times what happens, especially in software. Now, if you take an engineering project, in the beginning itself, they'll sit, plan, design, draw, finalize the project, after which both parties sign, agree, no changes after that. But in software, that never happens because most of the time the user is not able to convey what he wants to the developer. And the developer many times is not able to understand what actually the user wants. Now, this is the biggest challenge there. So changes keep on coming in. As the user starts seeing the software, he will come up with changes, or he should be a very experienced user. I mean, over a period of time, this will get reduced because earlier people did not have an idea about what the computer is capable of doing. But now they have a clear idea about what the computer is capable of doing. They know computer is only a tool, nothing more than that. So it's the people who code it have to get it done. So they explain things better, give a clear idea to the people. So but still you might have some changes coming in. So there you have to bring change control. You have to limit, give sufficient time to the user and the developer to understand each other and try to lock certain features which could probably change the dimensions of this. Now, if you are building a house, once the floor plan is designed, then the changes are not allowed to that. You cannot say halfway through, go give me an additional room here. No, it's not allowed because that will destroy the structural strength of the building itself. Once the floor plan is designed, then everything goes according to that. Maximum you can do is probably you can say, I don't want a door here, let it be an arc there, or please remove the window from this side. Now, these things can be accommodated as you build the house. But the basic plan of the building is never. So that is a control that you put. Because if you start making changes in the foundation of the building, then you don't know how the building is going to land. Finally, what will be the condition of the building? It's not possible. So here also in software also, because it's intellectual work, right? A lot of ideas keep coming in, which forces people to keep on changing. But don't do that. Maybe you feel that the new idea is good, but don't touch your basic system, because if you go to incorporate that new idea, whatever you have done till now might go into trouble. So you learn to control things on that. Don't allow changes to the maximum possible extent. So change control, then incremental development. That is another solution. Develop in small pieces so that every piece is shown to the user, his approval is received, and then you go to the next one. So that helps you to manage changes also. Right? You don't stick to what you have begun with. Right? People might have changes in ideas. So you develop the basic part of the project and then show it to the user. If he's okay with it, then go to the next level. Otherwise, you make modifications there itself and then go to the next level. Now, all this is just going to help you to curtail the damage that is created. It's not 100% solution to the damage that is going to be created. Shortfalls in externally supplied components. Now, if something is coming from outside, there could be problems in that also, which could affect your product. So how do you do it? You go for benchmarking, inspection, making sure that things are as per your requirement. Formal specification have to be provided so that the supplier is capable of giving you what exactly you want. Then put contractual agreement. So if a loss happens to you, you should be able to recover the damage from the supplier also. Then finally, quality controls. Before you start using the product, test the product properly and make sure that it is perfect. Right? Okay. Shortfalls in externally performed task. One is quality assurance procedures. If you have it in place, you can control it to a great extent. Then competitive design, right? Try to keep it as low as possible, competitive as possible. Then real-time performance problem that you can uh, confirm by simulating the product, prototyping, and then fine-tuning it. Simulation is doing mathematical modeling or something which will give it. This is not possible for everything. So for some cases, you can simulate. If it's a mathematical software, you can test it by simulation, right? But if it's a small uh, and financial application program, a billing software, then prototyping is the best method. That means you create a small software, run it, check it, show it to the end user, take his opinion, right? Ask him to operate and see that. So that is prototyping before you start working on the bigger part of the project. And then finally fine tuning it. Fine tune your software in such a way that it meets the requirement. So every now and then you go there and inspect it and try to understand if there is a gap between what is required and what is being done, tune it. Even it might be a very small thing, but on the long run, it might create huge problems, right? Development technically too difficult. That is another challenge. For that, you can do technical analysis, cost benefit analysis, prototyping, and training. So technical analysis is whenever a solution is developed, analyze it technically also, not only logically from a problem point of view. Technically, is it feasible? Right? Can you implement that system based on one is the technological feasibility, one is economic feasibility. You are spending lakhs of rupees for the benefit of thousands, which doesn't make any sense. Better you don't go for that solution itself because you're going to make a huge loss in the process. So cost benefit analysis, actually, that is what I was just talking about. The cost incurred and the benefit you reap out of it. There should be a match somewhere. Then prototype it. Create small models so that it is easier for you to handle. So the difficulty part can be removed and then train your people on the software and the system on the technology, what is required completely. Otherwise, it becomes difficult. If you don't, if you're trying to manage with people that you have, then you might land up in trouble as far as developing the solution is concerned. Then risk prioritization. Now, this is understanding which risk is the first to be addressed and which risk can be kept aside for some time. It is not urgent. So risks which happen and can create huge damage are normally the risks which have to be addressed first. You call it risk assessment. Risk assessment will help you to prioritize the risk. Risk assessment means nothing but trying to understand the damage a risk can cause to your function. Based on that, the more the damage is, the more important it is to handle that particular risk. So you will put it on priority. Now, risk exposure. One is potential damage into probability of occurrence. Now, that is very important. Probability of occurrence. It's a term which we have not seen before. When you consider risk, you must also look at, it might be a huge flood, say, for example. You must look at the probability of occurrence. Based on that, your planning should work. Otherwise, you might spend too much of money on managing the risk where the probability is very less. So a risk assessment, one is the damage it creates and the probability of occurrence also has to be looked into. Otherwise, you will not be able to feasibly handle that particular risk. Now, that is ideally. Potential damage, a money value, example, a flood could cost pounds 5 million of damage. You should have the monetary, what you call aspect of a damage. Probability. Zero of occurrence, that means absolutely no chance of occurrence, to 1, absolutely certain, right? So 0, 0, 0 is the probability of occurrence is nil, and 1 is the probability of occurrence to happen. Example, 0.01, 1/100th of a chance. So that will help you to understand the probability of occurrence. So that means the exposure of the risk that happens is equal to the damage created, which is 0.5 million into 0.01, which is equal to 5. 1 minute. Okay, now risk probability qualitative descriptors. Probability level high, greater than 50% chance of happening. Significance 30 to 50% chance of happening. Moderate 10 to 29% chance of happening. Low, less than 10% chance of happening. Say, for example, if you look at flood happening in non-flood prone area could be less than 10%. You can demarcate it as low. Then power failure. Now, this is very frequent, especially in cities. So you can say it is high, right? So you should be always prepared for that. If the power failure in your area is low, that means it rarely happens, then it's not actually necessary you maintain a generator, right? Or you can probably have a low capacity generator which will handle emergencies. That's all. But if your power failure is very frequent in your area, then it is the best to have the most what you call powerful generator in your organization. Now, qualitative descriptors of impact on cost and associated range values. See, high, greater than 30% above the budgeted expenditure, right? Then significant, 20 to 29%, right? Here it is greater than 30%. Here it is 20 to 29% above the budgeted expenditure. Then moderate is 10 to 19%, and low is within 10% of the budgeted experience. So high, greater than 30% above budgeted expenditure, significant, 20 to 29% above budgeted expenditure, moderate, 10 to 19% above budgeted expenditure, and low, within 10% of budgeted expenditure. Probability impact matrix. Now, this is the tolerance line that is allowed, right? Impact and probability. Probability is the chance of occurrence and impact is the damage it creates, right? So based on that, you can categorize, or you should be able to categorize and put it into this matrix, which will help you to understand how much importance you must give to each risk. Now here you can see that this particular risk R1 is the most, what you call, biggest risk that has to be paid the most attention. Here, if you look at it, the impact created is high. So again, you have to give some importance to this, but probability of happening is low. So that is why you can reduce the priority there, right? These does not fall under very significant this thing because one is moderate chance of happening, and of course it comes under a significant category. Now here the probability of occurrence is high, but the impact is moderate. So the priority can be designed accordingly. So if you can understand the impact of a risk and the probability of happening, you will definitely be able to balance in how effectively you can manage your risks. Now, risk planning. Risks can be dealt with by risk acceptance. That is, you accept the risk. You can't do anything. Flood. You can't do anything. So you accept it and be prepared for that, right? Then risk avoidance. Try to avoid risk. If you are sure that these risks are going to happen, take measures to avoid those risks. Then risk reduction, basically trying to reduce the chances of occurrence of the risk. Firefighting. Why do they keep boards like no smoking in this area and so on and so forth? Right? Because they want to avoid the risk itself completely. So they're trying to reduce the possibility of the risk happening by keeping away dangerous. When you're boarding a plane, they say no to certain type of goods. There is actually a method of reducing the risk. Then risk transfer. You can reduce the damage of risk happening to you to somebody else. Insurance is one best example, which is an example of risk transfer. Your building catches fire, it's covered under insurance. So the damage is reduced. Then risk mitigation contingency measures. Basically trying to reduce the impact of the risk and then keep contingency measures to handle the risks more effectively. Now, risk reduction leverage. Risk reduction leverage is equal to risk okay. So risk reduction leverage is equal to risk exposure before and risk exposure after divided by the cost of risk reduction. That will help you to decide how much you need to invest in risk management. Now, risk exposure before is the risk exposure before risk reduction. That is 1% chance of fire causing pound 200K damage. Risk exposure after is risk exposure after risk reduction. Example, fire alarm costing pound 500 reduces probability of fire damage to 0.05%. So reduce risk leverage is equal to 1% of uh, pound 200K, which is actually the damage that is caused, minus if you take measures, the risk probability is only 0.5% of pound 200K divided by the cost incurred in containing the risk. Now that is called the cost of risk reduction, which is 500 pounds, which is 2. Now risk reduction leverage is greater than 1, therefore worth doing. So that means that gives you a measure which helps you to understand that you have a value which makes or tells you to go ahead with investing so much money, right? To which will help you to reduce the possibility of the risk. So it is worthwhile to do it, financially feasible, financially viable, financially effective, to spend so much of money to cover up for so much of risk damage that could happen. So basically trying to find a justification numerically. That's probability chart, percentage probability of completion and days. Percentage probability of completion, accumulated percentage probability. So how many days it takes and the possibility of completion. 4 days, this much. Actually, it takes 10 days to complete the project in itself. Now, using PERT to evaluate the effects of uncertainty. 3 estimates are produced for each activity. Most likely time M, optimistic time A, pessimistic time B, expected time TE, which is equal to A plus A stands for optimistic time. That means that is your choice, your preference, right? Then into 4M plus 4M, that is most likely time, right? And then pessimistic time, the worst case, right, would be B divided by 6. Activity standard deviation S is equal to B minus A, B minus pessimistic time minus optimistic time divided by 6. Chain of activities. Task A, task B, task C. Try to find out the expected time here. And then the activity standard deviation. Chain of activities. What would be the expected duration of a chain A plus B plus C? The answer is C. A is 12, right? So 0.66 plus 10.33 plus 25.66, that is 48.65. Now this is applying this formula here. What would be the standard deviation for A plus B plus C? Which is square root of 12 plus 12 plus 32, which is 3.32. Now assessing the likelihood of meeting the target. Now taking measures, will you be able to meet the target? Now that is also something which you have to look into. Now say the target of completing A plus B plus C was 52 days. T. Calculate the Z value, thus Z is equal to T minus TE. TE, is expected time. And target of completing was 52 days. So number of days minus estimated time, right, divided by S. What is S? Activity standard deviation, possibility of deviating from the standard. In this example, Z is equal to 52 minus 48.33 divided by V2, which is 1.01. Look up in table of Z values, graph of Z values. Traditional planning approach and critical chain concept. First is the hardware selection. Starting week 1, it goes up to week 6, right? And then at the same time, you start with software configuration. Then at the same time, recruiting staff also happens. Now, after hardware selection, week 7 onwards, it is installation of the hardware. It goes up to week 9. Software, you start data migration, which goes up to the 8th week. Then draft procedures, which go up to 7th week. And once hardware installation is over and data migration is also done, you start with install and test, because this can be done only after these two things are completed, right? Then draft procedures, recruitment staff. After that, you start user training. Now, critical chain approach. One problem with estimates of task duration. Estimators add a safety zone to estimate to take account of possible difficulties. So always when you plan for 3 days, you make it 4 days, so that 1 day additional you keep it for safe. So that in case something goes wrong somewhere, you expect something to go wrong somewhere, it can be automatically taken care of. Estimators add a safety zone to estimate to take account of possible difficulties. Developers work to estimate plus safety zone, so time is long. No advantage is taken of opportunities where tasks can finish early and provide a buffer for later activities. Now, this is very important. Nobody's never, or in very rare cases, people try to complete the task before the allotted time. They always try to meet that time frame. It might be possible to complete the task prior to the allotted time, but still there is a basic tendency of. So that is the reason why they say here, you have an estimate, and if people know that there is a safety zone, there is a tendency of people completing the work only after estimated time plus safety zone, where the time is lost completely. Critical chain approach. One answer to this. Ask the estimators for two estimates. Most likely duration is equal to 50% chance of meeting this. Comfort zone. Additional time needed to have 95% chance. Schedule all activities showing most likely values and starting all activities on latest start dates. Right. So ask the estimators for two estimates. Most likely duration, 50% chance of meeting this. Comfort zone, additional time needed to have 95% chance. Schedule all activities using most likely values, and starting all activities 1 minute. And starting all activities on latest start dates. Now, most likely and comfort zone estimates. Most likely activity A6, comfort zone plus comfort zone 8, comfort zone here is given as 2. So we are actually showing the basic time required and time with a margin, which will give you an idea about how much space, how much time you have to, in addition to the basic time frame. Identify the critical chain, same as a critical path, but resource constraints also taken into account. Put a project buffer at the end of the critical chain with duration 50% of the sum of comfort zones of the activities on the critical chain. So you give 50% margin kind of thing. Then where Subsidiary chains of activities feed into critical chain, add feeding buffer. Duration of feeding buffer 50% of comfort of sum of comfort zones of activities in the feeding chain. Where there are parallel chains, take the longest and the sum of those activities. So this is now plan employing critical chain concepts. Same hardware selection. Here you can see the difference. Only difference is same. Test and install, user training, you have a feeding buffer. Here also a feeding buffer has been added. Along with that, there is something called the complete project buffer. Now, this is actually the safety zone you're talking about. So your deadline might be given as this, but technically you can afford to go to this. So if you are not specifying to the people about this project buffer, they might put it on finish the job on time. So you have got sufficient time of 2 weeks to test the project literally, right? You tell the people work is over and you start using the project. You have a buffer time to make corrections there until the project completely goes live after the 16th. So you're kind of putting a safety zone in the system. Executing a critical chain-based plan. No chain of tasks is started earlier than scheduled, but once it is started, is finished as soon as possible. Right? This means the activity following the current one starts as soon as the current one is completed. Even if this is early, the relay race principle. Now, no chain of tasks is started earlier than scheduled. Nobody will start the task earlier than the scheduled time. But once it has started, they try to finish it as soon as possible. That should be the approach when you take into consideration critical chain. Now, this also means that the activity following the current one starts as soon as the current one is completed, even if this is early. This the relay race principle. So as the time is not a just because you have 3 weeks doesn't mean that you have to complete the task only in 3 weeks. If you can complete it in 2.5 weeks, immediately the next task is initiated. You don't wait for that period to be over unless and until it is a sequence activity. If it is a sequence activity, the problem is you will not be able to start only before the completion of multiple phases. Now, one phase is completed in 2.5 weeks and the other phases are not completed in 2.5 weeks, then there is going to be a challenge or a question. You will not be able to start the next task until and unless all the 3 tasks are complete. If it is one issue dependent, then as soon as that particular task is over, you can start over with the next task. Executing the critical chain based plan. Buffers are divided into 3 zones, RAG: red, amber, green. Green, the first 33%, no action required. Amber, the next 33% plan is formulated. Red, last 33% plan is executed. Now, the risk management process in IT project. One is risk identification, right? So when you start a project, these are some activities which you have to do. First is identifying the risk, then risk measurement, risk assessment, determination of risk tolerance ranges, right? How much can you tolerate the risk, right? Then determination of possible risk responses. How do you respond to the risk? Now, all these are a part of risk analysis, right? Now, risk steering, us assigning a risk to a person so that it gets a direction. He is in charge of that risk. So if this risk happens, he has to do the necessary, is given a clear idea about how that risk is going to be handled, allocation of resources, make sure that you have a sufficient number of people and other resources available there. Then choosing a reaction to risk, right? How are you going to react to the risk? And then implementation of, now reaction also, remember, is very important. Sometimes the way you react to a risk can increase the damage also. Now this happens normally when you don't understand the fundamental reason behind the risk. You just jump at it and try to solve the problem without actually understanding the root cause of it. That increases the amount of damage it creates. Then finally, implementation of action. Right? Then risk control. Keep monitoring it. Have scheduled checks, right? At each stage, you try to schedule a check, which all are the critical stages, and based on that, you decide when to check, right? So that at each critical phase, you make a check, so that if you can find errors and bugs at that stage, it helps you to correct it there itself and go to the next level. Then finally, you should have a proper reporting system of all these activities. Now, this is not only for controlling the current stage, but also for controlling the future. This data that you collect during a project can help you in handling risks in a better way in the next project. So this data is very, very important. So summary in risk management is risk. You are managing risks, right? Categorizing risk. These are the most important thing that you must then dealing with the risk. So understanding risk, managing risk, categorizing risk, and dealing with the risk. These are the 4 things that you must understand as a part of risk management. Then comes change management. Now, why change management is looked upon as a separate area in itself is primarily because changes always keep happening, and changes are always looked upon by people with a little what you call discomfort, because you have been used to doing a task in a particular manner for so many years, and suddenly people tell you you should do it this way. Now, the question that comes into your mind is, you know exactly what you're doing, everything is going on properly. Why do you need the change? Because a person sitting in a particular position will not be able to understand the advantages of changing the process on the long term. Right? Okay. So no matter where you are in the system life cycle, the system will change, and desire to change it will persist throughout the life cycle. Right? Because after some time, technology might be a reason, policies might be a reason, method of functioning might be a reason, finding more effective ways of doing things might be a reason. Change is inevitable. Change will keep on coming, right? What are these changes? One is changes in business requirement, changes in technical requirements, changes in user requirements. Now, I can give you an example. Banking industry. Banking industry never used to charge us so much as penalty and other service charges earlier, because it was more of manual and salaries were very less. So expense for bank to run a bank was comparatively less. But soon came an age of new age banks, which were completely technology driven, customer orientation, new management principles, etc. Now, what happened is this forced banks to change based on their business requirements. Otherwise, they would slowly vanish out. You might have seen so many banks close down over a period of time just because they were not able to keep up with the current day requirements. So they were forced to change. Then comes technical requirements. Now, do we need to use computers? Yes. If you want to reduce the number of people, make the branch more what you call effective, technology is anyway there. So you should. Now, even if a bank says we are not going to charge you so much, our charges are going to be minimal, but we don't have mobile banking, internet banking and all. Will we take the pains of opening an account in that particular bank? Most probably no, because Today, we cannot think about going to a bank for withdrawing money or doing any other task. We simply want technology at our fingertips. We prefer mobiles, even laptops today. Nobody, I think, takes that. Everything is done through mobile banking. Only features which are not available on mobile banking, people sit on a laptop, log in, and then do things. Right? Changes in user requirements. That is another reason why change is inevitable. For that, again, you have to have project plan, how you're going to adapt to the change, test it, code it, change the data if necessary, and any other documentation required for the system. So these are the activities related to changes. Now, first thing that you have to understand is the software configuration part. The pieces, programs, documents, and data. Right? These are the three most important aspects of a software. The IEEE standard number 610.12/1990 defines a baseline as a specification or product that has been formally reviewed and agreed upon, that thereafter serves as the basis for further development, and that can be changed only through formal change control procedures. A baseline is a milestone in the development of software that is marked by the delivery of one or more software configuration items and the approval of these software configuration items that can be obtained through a formal technical review. So basically, a specification or product that has been formally reviewed and agreed upon that thereafter serves as a basis of further development, and that can be only through formal change control procedures. That is called the baseline. The baseline is a milestone in the development of software that is marked by delivery of one or more software configuration item, and the approval of these software configuration item is obtained through the formal technical review. So baseline also refers to a main area of completion, a portion of completion, what you call. Your software project, you will set milestones to complete this, that, etc., as you proceed. So at that particular point of time, you have one milestone to complete. That is what you say. Now that milestone can also be looked upon as a baseline, provided it is complete in itself. Now, software change management repository. I think this will continue in the next class. Please complete the quiz. Quiz has been posted. If somebody can try it out and tell me whether it's accessible or not, would be helpful.